Here's the deal. I'm going to go through the quiz. We're all retaking it tomorrow.
Oh, okay.
Okay? So we'll go through it, and this will be a practice run. Tomorrow's grade will count. Okay.
So this is the pre-test.
Yes, this is a pre-quiz, apparently. Okay.
Get better than a 60 on it. I'm doing good. I'm making better than a 50.
Okay. So on number 1, we're looking for factors of 6 that add up to negative 5. So if 6 is positive, both numbers have to either be what?
Negative.
Yeah, both have to either be negative or they both have to be positive. And the way I determine which one it is the sign here. So they both have to be negative. A lot of people put 6 and 1, but negative 6 times positive 1 does not equal positive 6. But negative 3 times negative 2 does. Okay, the question said to solve, not just factor. Okay, so once you get it factored, then you set each factor equal to 0. And solve. So your answers are 3 and 2. Okay. Number 2. First thing I need to do, because it's a quadratic, is get everything to one side and set it equal to 0. It's always how I begin. So if I add 4r squared, I get 9r squared. If I add 4, I get this. Now several of you use the bottoms-up method. Perfectly fine, but in section 2 I went through some shortcuts, some pattern methods. And the first pattern method we talked about is if both ends are perfect squares, you take the square root of both, you write it twice, and the middle sign is the sign in the middle here. Then you can check it and make sure it worked by taking this times 2 to see if you get 12. And you do. Okay? The downside to the bottoms-up method, I would say 80% of you forgot to divide by the number you originally multiplied by.
Yeah.
And if you're going to forget to do that, you better start looking for patterns so you don't have to do the bottoms-up method when you don't have to. You know what I'm saying? Sometimes you're going to have to do the bottoms-up method because you can't do this. But if you start seeing some of those shortcut patterns, it'll save you from possibly missing one using the bottoms-up. Okay? If I use the bottoms-up, 9 times 4 is 36. To factor that, I'm looking for factors of 36 that add up to 12. But I'm not done yet. Now I've got to divide by what I originally multiplied by and simplify. Right? So on this one, to solve, I set it equal to 0. Oops. I'm going to do this. Right? Subtract 2, divide by 3, you get negative 2/3. And it's going to be the same here. So it's the same root twice, negative 2/3 twice. Over here, when I set r plus 2/3 equal to 0, r is also equal to negative 2/3. So you can get the same answer using both methods. And if all you want to remember is bottoms up, that's fine, but make sure you do it right. If you forget to divide, that's an issue. The special factoring methods we learned in section 2 work when you have perfect squares. Okay, which we did in this case. Next one. Okay, if I want to factor it, this is another one of those. We learned 2 special methods when you have perfect squares and a middle term, or 2 perfect squares with a subtraction sign between them called the difference of squares. If it's a difference of squares, you take the square root of both, and you write them twice, but one is positive, one is negative. The reason is that's what makes that middle term drop out. They both can't be the same sign. One has to be positive, one has to be negative. Okay? And then you solve. Six. There's always two answers. Sometimes they're the same, but they're duplicates. Okay, another way you could have solved this one is dividing both sides by 4 to get x squared equals 9. Then take the square root. But when you take the square root, you must always remember it can either be negative or positive to give you 9. Okay, so if you're going to use that method, you've got to remember there's always two answers. If you take the square root of a number, it's always plus or minus. Because it can be negative 3 times negative 3 or positive 3 times positive 3 to give you positive 9. Okay. Next 3, we're simplifying radicals. So when you simplify a radical, you're looking for the largest perfect square you can think of that goes into that number evenly. Remember your perfect squares, 1, 4, 9, 16, 25, 36, 49, and so on. So always have those in your head when you're trying to figure out factors of this number. There are other factors of this number that don't have perfect squares. Those are perfectly fine, but if you're trying to simplify, those aren't going to help you. Okay, so we're looking for perfect squares. So 9 and 7 is how that breaks down. Right? And the square root of 9 is 3. 3 squares is 7. Next one. 5 square roots of 3 times the square root of 6. Now, if you're adding, the radicands have to be the same number. But if you're multiplying and dividing, they don't. All you do is you multiply the radicand and you keep the radical there. So the square root of 3 times the square root of 16 is 5 square roots of 18. Several of you got that far. But the key here is recognizing the square root of 18 can be simplified because there is a perfect square that goes in evenly to 18. Okay, so we have 5 times the square root of 9 times the square root of 2. Well, 5 times the square root of 9 is 15 because the square root of 9 is 3. And then we have square root of 2 left.
I mean, everything's so much harder than everything.
Next one. It was the square root of 25 over 3. You can split this up if it doesn't go in evenly and write it this way. The square root of 25 is 5. But we learned this in section 4, I think, 3, that you can't have radicals in the denominator.
So you gotta bring it up.
Okay, so the way you bring it up is called rationalizing the denominator, and you just multiply top and bottom by the same radical. So this is 5 square roots of 3 over 3. Square root of 3 times itself is just 3. Any radical times itself is just the radicand. Okay? All right, next one. Solve the equation by factoring. We're going to have to use bottoms up here. So we multiply 2 times negative 14. Factor. And then, don't forget, divide by what you multiplied. So x is equal to negative 7 halves or 2. Letter B. Okay, number 8. This is what factoring does for us, is actually solving real-world problems like this. The volume of a box is 400 cubic meters. Well, the formula for volume is length times width times height. The width of the box is 2 meters. The length is 10 more than its height. And the height is just h. Right? So I have 10 plus h times 2 times h is equal to 400. With me so far? Okay, this is really just 2h. So I'm going to distribute 2h to 10 and 2h to h. Okay, anytime I see a square, I know it's a quadratic. To solve a quadratic, no, I have to get it set the equation equal to 0. Okay, first thing I always do to solve is factor out any common factor, 2. Looking for factors of 200, one's positive, one's negative, that add up to 10. 20 and 10? I divide everything by 2. I took 2 out of 2h squared. I took 2 out of 20h. Okay, I should do this. Then I divide 2 over here. 0 divided by 2 is 0. So I can drop it at that point. If you're just factoring, it has to stay. But if it's equal to 0, that number you pull out, if it's just a number, not a variable, it goes away. Because when you divide both sides by 2, you get 0.
It is absolutely none of that.
Yep.
I just literally just took 400 divided by 2 divided by 10. Got lucky, I guess.
Got lucky.
I tried to do that. I don't even know what I tried to do.
So there's always 2 answers. In this case, one of them is negative, so that can't be it. So h must be 10. Well, if h is 10, the length was 10 plus that, so the length is 20. And there it is.
I don't know how I got 4 and 5.
I don't even know how I got in the 60s.
What's your question?
How come, wait, think about it. How come the height didn't move to the, oh, I get it now, okay.
Next one, another bottoms up. And this time we're not solving, we just want to factor it. Is there something common to all 3? No. 16 times 5, 80. So I'm looking for factors of 80 that add up to 42. They're both negative because 80 is positive. They're either both positive or both negative. The middle term's negative, so they must both be negative. Well, 40 and 2. I can't forget, I multiplied everything by 5. So I have to divide everything by 5. And the bottom's up when you're factoring. This comes up. And there it is. Everybody who missed this one just forgot to divide by the 5. Next one. This I can look at, but I've got two perfect squares with the subtraction between. This is a difference of squares. This is the special factoring method, where you take the square root of both, write it twice, and one's positive, one's negative, which is why the middle term drops out. That's it. Next one. To the fifth. Yeah.
So for the last one,
Uh-huh.
for number 10, you said the square root should be like positive or negative.
Uh-huh.
So for 64y, the square root would be negative 8y and 8y.
The middle sign needs to be positive and negative.
Okay, but it doesn't matter for the other one.
Well, it does, because it doesn't matter whether it's first or second, but the first term has to be positive, because if I have a negative and a positive, I'll get negative 64y squared, and it's positive 64y squared.
I know it started with 3u squared.
Yeah, this 49, one's positive, one's negative, which gets you the negative 49.
Gotcha.
Minus 45u to the fourth. So I can see right away a u to the fourth is common to all four, or all three, but a 3 is also. When I pull a 3 out of 24, I have 8u squared. 3 out of 6, that's 2u. And 3 out of 45 is 15. Not done yet, though, because this is factorable. So I'm looking for factors of 15 times 8, 15 times 2 is 30, 30 times 4 is 120. Factors of 120, one's positive, one's negative, that the difference of them equal 2.
12 and 10.
But then I've got to remember, divide by 8 and simplify. This is 3 halves. And this is 5 halves. All right? 5 fourths. And I still have the 3u to the fourth. So this becomes 2u minus 3 and 4u plus 5. Letter A. Solve using factoring. Bottoms up again. Three times negative 12 is 36. Looks like 9 and 4. Then I have to divide this by 3. And x minus 4/3. So x equals negative 3 or positive 4/3 when I set both of those equal to 0. Letter D.
Wait, I have a question.
Mhm.
Shouldn't you have brought the 3 up by the end?
If I'm just factoring, it doesn't matter. Okay, so if I have 3x minus 4 equals 0
No, I mean in your dividing.
here,
Yeah, shouldn't that have gone up since you can't simplify?
right, 3x minus 4, and then I set it equal to 0. I add 4, divide by 3. So when I'm solving, if I don't bring it up, it's the same thing. If I'm just factoring, yes, you must bring it up. But if you're solving, you bring it up, then you're going to undo it anyway.
Oh.
So either way, I get 4/3.
Oh.
Good question. All right, number 13, simplifying. So I can break apart both of these This is the way I do it. Find a calculator. I know 605 is divisible by 5. And that's 121. Right?
Yeah.
And the square root of 121 is 11. And square root of 5 times the square root of 5 is just 5. And I can't do anything with the square root of 11. So I just take 2 times 11 times 5. 110 square roots of 11.
Multiply both by 5.
The square root of 5 times the square root of 5 is just 5.
Oh, wait, okay.
That makes sense.
Yeah, I understand. Alright.
Where'd I lose you?
You did.
Excuse me for interruption. Students with a pass to see the EWC rep, please come to the Student Center at this time.
You want this?
Here's the worksheet for today, Braden.
This for you, you want this back?
No.
You have one thing here.
You too. Okay, last problem.
I understand.
You too. Okay, you could go ahead and just break apart the numerator and break apart the denominator. What I did is I noticed, I know the numerator and denominator. Remember, when you are dividing or multiplying, you can just divide or multiply the radicand. So this is the same thing as okay. So if I just focus on this fraction and reduce it as much as I can first, I know already they're both divisible by 10. So that gets me to 726 over 396. I look at those two, I know they're both divisible by 6. It's 121 and 66. Look at both of these, I know they're both divisible by 11. This is 11 times 11. This is 11 times 6. So those 11s cancel. I'm left with the square root of 11 over 6. But I can't have a radical in the denominator. So I multiply top and bottom by the square root of 6. So it's the square root of 66 over 6. Okay, I recorded this if you want to watch it again tonight with your quiz in hand. Okay, and the quiz retake will be tomorrow in class. Whatever you get on the retake is your grade for the quiz.